Welcome back. Today we'll use sum and difference formulas to evaluate more trigonometric ratios. So we're always going to go back and reference our special triangles, but using these formulas and these identities help us to broaden our range for angles. Okay, so for the first example, let's consider the cosine of 165. So if we're going to add two angles to make 165, well, we could add 135 and 30. So I can rewrite this as the cosine of 135 plus 30, and that's in degrees. Now going back to the formulas, I would be using the sum of u plus v. My u would be 135 and my v is 30. So I can rewrite this as the cosine of 135. I'm just going to drop the degree for this example. Cosine of 30 minus the sine of 135 times the sine of 30. And just thinking of our special triangles, we know that 135, well, that's just going to be root 2 over 2, but it's a cosine, so that's going to be negative root 2 over 2. Cosine of 30, that's in the first quadrant, so that's just root 3 over 2. The sine of 135 is also root 2 over 2, positive, and the sine of 30 is 1/2. And we could simplify that to be negative root 6 minus root 2 over 4. Now let's consider 13 pi over 12. Now whenever I'm using these radians, I like to break them apart so we can see sine of 13 pi over 12. Well, I can break that into 4 pi over 12 plus 9 pi over 12. And remember, 4 pi is really just, 4 pi over 12 is just reduced to pi over 3. And 9 pi over 12, well, that would reduce to 3 pi over 4. So now we could use that sum formula for sine. So the sum of u plus v, our u being pi over 3, and our v being 3 pi over 4. So I'm going to rewrite that as a sine of pi over 3 times the cosine of 3 pi over 4 plus the cosine of pi over 3 times the sine of 3 pi over 4. And we should know these special triangles of the unit circle very quickly and be able to identify these. So this is root 3 over 2 times negative root 2 over 2. Cosine of pi over 3, that'd just be 1/2. And 3 over pi over 4, that's just also root 2 over 2. So we're going to have this simplified as negative root 6 plus root 2 over 4, or you can rewrite it as root 2 minus root 6 over 4. And if you notice, we're having those same values, the root 6 and the root 4, because we're having a 30, 60, 90 and a 45, 45, 90. So we're going to have some of those common ratios. Now let's look at the tangent of 17 pi over 12. Again, I'm going to split up the 17 pi into 2 pi and 15 pi. So this will be tangent of 2 pi, which is 2 pi over 12 would just be pi over 6. And then 15 pi over 12 would reduce to 5 pi over 4. All right, and so then for the tangent, remember the sum is going to become a ratio of tangent u plus tangent v over 1 minus tangent u times tangent v. And those formulas, you could make sure you have them on the side whenever you're completing this homework until you have them memorized. So tangent of pi over 6 plus tangent of 5 pi over 4, 1 minus tangent of pi over 6, tangent of 5 pi over 4, and then we just have some algebra to work through. So let's just simplify this. This is just going to be root 3 over 3 plus 1 minus root 3 over 3 times 1. So I could rewrite this as 3 plus root 3 over 3. And this could be 3 minus root 3 over 3, which will be 3 plus root 3 over 3 minus root 3. Now that's okay if we're saying, okay, leave it as without a rationalized denominator. If we want to rationalize the denominator, we'd have to multiply the top and bottom by root 3 plus root 3. So I'm just going to rewrite this here just to show the work. So that's 3 plus root 3 over 3 minus root 3, multiplied by the conjugate. And this will be plus. So we'll have 9 plus 6 root 3 plus 3 over, that's just 9 minus 3. So 12 plus 6 root 3 over 6, which reduces to 2 plus root 3. Okay, all that work to rationalize that. Okay, so for all of these, the key part, whenever we're using the sum and difference formulas, is to recognize them, okay, and see which angles we could use. And remember, we're going back to those 30, 60, 90s and the 45, 45, 90s. For example, 2, try to identify which sum difference formula we're using here, and then simplify that value. Pause the video and then come back to check your work. Okay, let's check our answers. So hopefully you're able to identify that this formula was the sum of the sine angle. So sine of 265 plus 50. When we add those together, we get sine of 315 degrees, which we know is in the fourth quadrant. It's 45, 45 degree angle or triangle. So that's going to be negative root 2 over 2. So knowing that unit circle is really important for this section as well. For cosine 250 times cosine 130 plus sine 250 times sine 130. That's the difference of the signs. And so if you notice that if it's a sum, the formula would be a minus. So cosine of 250 minus 130 is 120, and that's going to take us in the second quadrant. So the cosine is negative 1/2. Now considering pi over 9 and 7 pi over 18, well, I just did a little easy operation with LCDs, find the common denominator, and we know that the tangent of pi over 2 is undefined because the cosine of pi over 2 is equal to 0. All right, for the next example, I actually want you to pause the video and try this one first. So you have two angle measures, U and V, both of which are in quadrant 4. And you want to find these sums and differences. So the sine of U minus V, the cosine of U plus V, and the tangent of U minus V. Pause the video, like I said, and come back to check your work. For angle U, we know that that's going to be in the fourth quadrant, so the sine is negative, but the cosine will be 3 over 5. And then for V, we know that that cosine was given, which is 12 over 13, but the sine of V would be negative 5 over 13. So just using those Pythagorean triplets, 3, 4, 5, 5, 12, 13. Okay, so for sine of U minus V, right, this is good practice for the sum and difference formulas. That's going to be the sine of U, which is negative 4/5, times the cosine of V, which is 12 over 13, minus cosine of U, which is 3 over 5, times the sine of V, which is negative 5 over 13. And we get negative 33 over 65. For the cosine of U plus V, well, that's going to be the cosine of U times the cosine of V minus the sine of U times the sine of V. So the cosine of U is 3/5. Cosine of V is 12 over 13. Sine of U was negative 4 over 5. And then the sine of V was negative 5 over 13, giving us 16 over 65. For the tangent of U minus V, well, we could plug those in and get the tangent. So the tangent of U is negative 4 over 3. Remember, the tangent of V is also negative. It's going to be negative 5 over 12. So from here, you just need to find a common denominator and reduce, so we have negative 33 over 56. Now for the next example, they're very similar to what we did earlier in the chapter with proofs. So I'd like you to pause the video and see if you can simplify these proofs. Try to work on one side using these sum and difference formulas. Okay, let's go through these. So hopefully right away you start to see the difference of the sign. So sine of x times cosine of pi over 2 minus cosine of x times sine of pi over 2. And when we simplify that, we get negative cosine x, which looks like the right side. For the second one, well, this was a little tricky. So we do have a difference of cubes on the left side. So we're going to factor that, and we can see right away that the cosine of beta can cancel out the cosine of beta minus the sine of beta can cancel out the denominator. And so we're left with sine squared of beta plus cosine squared, and that equals 1, plus cosine of beta times sine of beta. Now here's where we get stuck. And so whenever we have a proof, we can work on one side, the left side, and we kind of got stuck there. So we can actually go to the right side and start to try to make that equivalent to the left side. So we have 2 plus 2 sine of 2 beta over 2. And then we can simplify that to be 1 plus 1/2 of sine of 2 beta. And so we end up just using this sum formula right here. So sine of beta plus beta. And so when we add those together, we get 1/2 times 2 of these sine betas cosine beta, which reduces down to cosine beta times sine beta. And so we can end up with the left side equaling or being equivalent to the right side. For the next one, it's a little tricky. We could factor out a negative. So we factor out the negative and we get cosine. We can realize that this is the sum of the cosine. So that'll be cosine of, or the difference, sorry. So that'll be cosine of 2 theta. And we could rewrite that as a sum of the angles. So that's cosine theta plus theta. And when we distribute the negative, we end up getting 1 minus cosine squared plus sine squared. And we can put or substitute that with sine squared. So then we get 2 sine squared theta. Okay, for the next page, we're still using sum and difference formulas. And you can notice right away that this is the difference of tangent. So 3t minus t, which would be tangent of 2t. And then we can actually use the sum formula. So that'll be tangent of t plus tangent of t over 1 minus tangent of t times tangent of t. And then we get the left side to look like the right side. So it'll equal 2 times the tangent of t over 1 minus tangent of t squared. For the next one, it's a little bit tricky. So we're using the sum formula for cosine and sine. And then when we simplify the left side here, we get 2 times the sine of x times the cosine of x over sine of x. And then what I could do is make sure I write down here this right here. So this was negative minus cosine of x. Well, I'll just rewrite this as cosine squared sine squared over cosine of x. So just be careful when you're distributing this negative. So we'll have minus cosine squared plus sine squared. And then we can simplify the cosine squared, so we get cosine squared plus sine squared in the numerator. And we can replace that with 1. And so we'll have the left side equaling or being equivalent to the right side, which is secant of x. For these last few examples, we're actually going to go back to right triangles and practice using these sum and difference formulas. So here we have sine of arctangent of 1 plus arccosine of x. And so remember, these are talking about angles, so that we could say that's u and v. So really it's saying what's sine of u plus v. And we know that that formula is just sine of u times the cosine of v plus the cosine of u times the sine of v. And so we just have to figure out what these values are going to be. And so it's probably just easier to just redraw a triangle. So we'll say this is u, and if arctangent is 1, that means it's opposite over adjacent, so that's 1 and 1. So that must be a 45, 45, 90 triangle. And then for the next one, I'm going to draw it down here. So for v, if we know that arccosine is x, then the adjacent is x, the hypotenuse would be 1, and then the opposite side must be 1 minus x squared. We just use the Pythagorean theorem. So from here, we can actually just figure out the value. So sine of u would just be 1 over root 2. Cosine of v, well, we already were told that in the beginning here, well, that's going to be x. Cosine of u, that's also 1 over root 2. And the sine of v, we figured out with the Pythagorean theorem, that's going to be 1 minus x squared. So we can write this as x plus the square root of 1 minus x squared over root 2. Now we can rationalize that as well by multiplying the top and the bottom by root 2. So I can write that here. So that would also be root 2 times x times 1 minus x squared. We can simplify that too, I guess, some more, but over 2. All right, for the next one, we're going to use the sum and difference formulas to solve it. So remember, we're going to have to first simplify this. So sine of x plus pi over 2, that's going to simplify into with the formula. So we have sine of x cosine of pi over 2 plus cosine of x times sine of pi over 2. So that's right here. And then for the next one, sine of x minus 3 pi over 2, well, that's going to be sine of x cosine of 3 pi over 2 minus cosine of x times the sine of 3 pi over 2. And that's all going to equal 1. Okay, so from here we can actually just use what we know about the unit circle. So this is just going to be sine of x times 0. I'll write it out, but we know that that's going to cancel. This will be cosine of x times 1, because sine of pi over 2 is 1. Then we have sine of x here. Cosine of 3 pi over 2 is also 0. Minus cosine of x. And sine of 3 pi over 2, that's going to be negative 1. So we can cancel all these out. And then we're going to have cosine of x and cosine of x equals 1. So that's just going to be 2 cosine of x. And then we can solve for cosine of x equals 1/2. And we know that that cosine will equal 1/2 at pi over 3 and 5 pi over 3. So using those sum and difference formulas to simplify the equation, make it a little bit more complicated here, but eventually simplifying and solving for that. Now the last thing we want to go over is the difference quotient. And you probably remember that from the beginning of the year. So remember, the difference quotient was looking at the changes in the x over the changes of the y's over the changes in the x. So remember, difference quotient was f of x plus h minus f of x over h. So we're using sine of x. So we're going to write this as the sine of x plus h minus the original function sine of x all over h. Now you can see we're going to use that sum formula. So we know sine of x plus h, well, that's going to be sine of x cosine of h plus cosine of x times sine of h minus sine of x over h. Well, that's pretty much as simplified as we can get, but we want to try to get the h's all together and the x's separate. So what I'm going to do is, we do have two terms here with sine of x. So I'm going to actually put this at the end of the term. So we'll have cosine of x times sine of h minus sine of x plus sine of x cosine of h all over h. So we can start to separate these, because the first one will just be cosine of x, and then we can essentially have those h's together, sine of h over h. And then for the second two, we can factor out the sine of x, and then just really have something with an h. So we have 1 minus cosine of h over h. So that's as far as we can get with the difference quotient, but using those sum and difference formulas. Well, I hope this lesson was helpful, and I'll see you all in class.